So welcome to today's session. Today's session is about data synthesis in systematic reviews. And in systematic reviews, you can have a narrative synthesis or you can have a meta-analysis. So we are going to be introducing a meta-analysis. Now, the thing about this lecture is that it's a lecture that is very applied and you're going to learn by doing. And that's why your next assignment would be that for the 7 studies we identified, you're going to synthesize it, and that will be your next assignment. And you guys have to work in group to synthesize it to see if it answers a research question that we had. But that is how we progress with systematic reviews. So, generally for these lectures, we usually see your quiz and everything, but just one person took the quiz by this morning. So that person is going to receive breakfast from me this week. I checked at 5 p.m. and a second person had taken it, but that's very late. Generally, the law is to take the quiz by Thursday, 23, by the close of Thursday. So the person who did the quiz in time is going to receive breakfast from me. And yeah, we're going to continue. So no quiz overview. It was just a review to get you guys to know. So like I said, before each lecture, I send you guys a pre-read and a quiz just so that you get those basic facts understood or clear. And the pre-reads are very simple to read. You can just read it like a novel. You don't need to memorize anything. You can just read like a novel, and the quiz is going to help you retain the information. But for those who read, fine and good. For those who don't read, still fine and good. The materials are there. The good thing is that you're going to have access to the materials up to 1 month after the course. So after 1 month, all of you will lose access to that timetable. So let's make progress. So where are we? We are here. So we've gone through formulating a question, the structure of a protocol, formulating your stress strategy, going through screening. Now we've done extraction and risks of bias, and now we are at synthesis. So you see that we are approaching the end of this mentorship. And congratulations, all of you who have been active in doing the assignments, in making sure that you understand the various steps, because again, like I said, this is applied knowledge, nothing else. You are not learning it for anything. You're going to see how we apply the things as you go further. And that's why I brought in the sample study so that you actually try your hands on it, so that when you're working on your own study, it will be faster and easier for all of you. Um, so why is this session important? Afai, can you tell me why synthesis is important in a systematic review? I'll take it that Afai cannot hear me. So generally, synthesis is a phase where you make sense of everything that you have, right? You have a research question and you have a systematic review you're doing, but you don't just need to have collection of studies. You need to be able to answer that one question that you ask when you started in the beginning. Good. And it should always be a structured and transparent thing, and it should always be consistent with the protocol. That's why we need to write the protocol before we even start doing it. And generally, you have two outcomes. It's either a narrative synthesis or it's a meta-analysis. So there where you need to assess for risk factors and every other thing. Now, at the end of this lecture, you guys will have an idea of what the narrative synthesis is. You understand what the meta-analysis is. You understand what are the effects measures. You will see how to interpret what we call a forest plot and the effects measures and heterogeneity, and also decide when it's appropriate to do a meta-analysis. I mean, based on your topics, we'll see if a meta-analysis is feasible or if all of us are going to do narrative synthesis. So that's it. But that's what we are going to be doing at this end. If you can hear me, send a thumbs up, unmute and say you can hear me. Good. So Generally, this is our workflow. So we've already done progress check, the lecture now, and then we have a demo, and then you guys will present. So that's it, and then we have a Q&A at the end. That's it. So we all started, right? We conducted a question, we then search, and then we've extracted data. So the end of the pathway is that you need to make sense of all what you've extracted. And to do that, you need to decide if your synthesis is going to be a narrative synthesis or it's going to be a meta-analysis. So the first thing for you to understand is to ask yourself, what is the nature of your PICO and what is the nature of your outcomes? So do your studies all address the same outcome? So again, going back to the assignment I gave you guys, could you perceive that all of them were having the same outcome or were the outcomes very different? Was the population intervention and comparators similar enough? And then is the effect measure, by effect measure, we mean like, okay, were they measuring the relative risks? Were they measuring the odds ratio? Were they measuring the hazard ratio? Was it compatible among studies? Now, the rule of thumb is that if this is compatible among studies, then you should consider doing a meta-analysis if that is compatible among studies. If it is not, then we are going to do a narrative synthesis. Is that point very clear?
No, it's not clear.
All right. So you guys are going to permit me to just let's go further. I hope it's going to be clearer. But the thing is, if you're measuring weight, let's say BMI, or let's take BMI, and you do a systematic review to assess how BMI varies across all of the studies. So the first question you need to ask yourself is are all of those studies measuring BMI? Yes or no? So is it the same outcome? Are we assessing BMI? Or are they measuring very different outcomes? Now, if it is a yes, it drives you towards a system, a meta-analysis. Now, are the populations or interventions and comparators, so that's your PICO, are they similar, right? Are they similar? So basically, can you compare those populations? So are we looking at adults? Are we looking at children? Are we looking at both adults and children? Things like that. Are we looking at hospitals only? Are we looking at community data? That's what you need to see. And then, what is the effect measure? Effect measure. So, for instance, they are measuring BMI and they want to see if BMI can be associated with, let's take heart attacks. And so they are measuring the hazard ratio or the odds ratio or the relative risk of somebody who is obese to having a heart attack. So in all the studies, can you find heart attack? Can you find odds ratio, risk ratio, and all of those things? Can you identify them so that you can assess them? So if all of these things are identifiable in all of the studies you've screened and assessed, then you consider that you're going to need to do a meta-analysis. If the studies are not similar in any way, then you're going to do a narrative synthesis. Is it clear now, Peter? Patrick? I mean, that's the most important thing to note is are you doing a systematic review with meta-analysis or just a systematic review?
Yeah, it's clear though. Thank you.
I hope it's clear to everyone. So, what is a narrative synthesis? It's not just that you just talk, paper one said this, paper two said this, paper three said this, and you're done. No. You want to group things according to outcome. What did they assess, right? Or intervention type, or by population, or by setting. But it's always good to group by outcome because that is what the study was aimed at assessing. Okay. And the most important thing is for you to always highlight if the effect was positive. So, did BMI increase the risk of stroke or not? So, that's where we talk about the direction of effects. And again, you need to talk about how similar the studies were, so how consistent were the studies and how different were the studies when it comes to what they measured. And then again, can you discuss the methods? Can you discuss the population? Can you discuss the risks of bias? So these things that we have already done, it is this point now that you come now to see, okay, what can I talk about in the risks of bias? What can I talk about with the change, the nature of the populations? What can I talk about when it comes to the methods that the studies use? And again, like I said, you need to avoid a study by study storytelling with no structure. You want to structure things by outcome, by intervention, by methods, by that, but that's how you discuss it. And so really it's always about your outcome. I hope that this is also clear. We're going to look at those papers and you're going to see how they structure their things. That's why I sent those papers to you guys to look at them. But again, a simple workflow that you can use for your narrative review is that first, we always talk about the study characteristics. That's why in that extraction sheet, you saw that we had author, date, title, sample size, nature, whatever, before we started seeing things about machine learning, which were the particular outcomes. So that's what fits in your table one. If any of you had a look at the articles which we are going to look, you see that there's always a table one which talks about the various characteristics of the study. That's it. And then you have a main outcome. So your main outcome, what was your main outcome? So in our demo study, we're looking at the risks of how well machine learning methods can predict cardiovascular risk. So basically, we are trying to, our main outcome is cardiovascular risks. So that will be how we would discuss it. And if we have any other secondary outcome. So again, you do that main outcome A, main outcome B, or if you have just one main outcome, you don't need a second main outcome. And then maybe you can have secondary outcomes like some other associated topics that you want to talk about, and then you discuss your risks of bias. Now, if your review question has two outcomes, which one? I mean, this is I'll just explain to you because I don't think you guys will be able to answer this question, but I'm going to show it to you guys. But if you have two outcomes, which one would you consider to be your primary outcome, and which one would you consider to be your secondary outcome? Can anyone try to answer that question? Agbo, are you there? Can you answer?
Yes, doctor.
What's your answer, sir?
Sorry, doctor. I did not get the question properly.
It's on your screen.
Okay, that if your review question has two outcomes, which one is primary and fine? The review question, the review question has as main outcome the, according to me, it will be the question that answers the outcome that answers directly the question.
All right, thank you very
I
much.
don't know how to put it, but
That's
in okay.
you don't need to you've said it well. It's actually the outcome that answers the question that you ask. That's your primary outcome. All right. Now, there is something called systematic review without meta-analysis. So this is a standard approach where you need to pre-specify how you would group your studies. You would use a consistent direction to effect reporting. This simply means that you're going to say BMI increases the risk of cardiovascular events or not in the same directions, and then you're going to use figures and tables to reduce bias when you're narrating. And then you're going to report uncertainty and limitations very clearly. So, swim is when you know that your data is not very uniform, that's what you move to doing. And one of the studies use the swim method, so we're going to look at it shortly. Visual tools, again, you definitely have your table one that serves as the first table. in your systematic review. And then you have your outcome table. So you might have two tables. So you don't need to put your study characteristics and outcome table as one. You separate them. And then you can have multiple plots depending on how well you want them. But a harvest plot is for very diverse studies where you just want to show how the studies have moved over time and have a structured summary. So this is just an image to show that it's a harvest. But the bubble plot, it's very good when you're mapping evidence over time. So the bubble there represents the size of the bubble represents the size of the topic, and then the colors vary depending on whatever interest you have. And then over time it shows. The next one is a heat map, which is really good when you are having various outcomes, but you want to show it in one single dashboard. So you can tell us that as these colors are changing, it means this, as this is growing, this direction is this. So yeah, if you look at this demo, red shows that it has a higher score. So we're seeing the closer it is to red, it means the score is high, something like that. The further blue it is, it means it's low. But these are just ways of presenting it. And we're going to just look at plots to see how it goes. So like we said in the beginning, if your data is not uniform, if your data is not similar, you're going to do a narrative review, a narrative synthesis, or a systematic review without meta-analysis. Or you're going to do a scoping review, which is mapping evidence. Now, if your data is very uniform, you have a common outcome, then you're going to do what we call a meta-analysis in addition to the systematic review. And meta-analysis simply means that you bring together the estimates of multiple studies. So if all your studies were assessing body mass index, we're going to bring them together and then assess the effective size, the effect size that was used to assess body mass index across all of those studies. So, I mean, if you look at this image, that's what I'm just trying, it was just this image just trying to say, okay, you're going to bring multiple studies and you're going to put them into one diamond to say, okay, this is the uniform effect that BMI has on the risks of having stroke among adults based on this systematic review. So each study contributes to the effect size, which is a diamond, that you're going to see very soon in a plot. And then studies are weighted often larger, more precise, and more weight. So studies that have a larger sample size, they'll have a larger square, something like that, sort on the plot that we are going to see. And then they'll have a narrow confidence interval, which I'm going to explain to you guys. But in a meta-analysis, what's most important is that you're going to have a pooled effect estimate. So by pooling, we mean it's not just for one study, it's for all of those studies. That's why the word pool comes in. That's just a statistical way to say that we are bringing several things together as one. And it's confidence interval. So CI stands for confidence interval. And then you're going to have an assessment of heterogeneity, which is I square, and then its chi-square value. So heterogeneity just simply tells us how variable were these topics. Were they very variable or were they uniform? That's what heterogeneity tells us. And then you have to plot your study. You don't just report it, you have to put it in a forest plot, which is what we are going to see in a couple of slides. But that's what the meta-analysis is. Patrick, can you summarize what you understand by a meta-analysis?
So from what I heard, I think meta-analysis is just to synthesize the systematic reviews which have um, compatible outcomes in which the studies can be compared to each other and in which the outcomes have something in common. That is, you're going to use the meta-analysis to present, that is to present your results using the various output form that you just explained. That is the pool effect, the heterogeneity, and the forest plots. That otherwise we present our synthesis using narrative synthesis. Okay.
All right. Thank you very much, Professor. That's very well done. It shows that you are in class, you are not sleeping. Very good. Nice. So that's what a systematic review is. And like if you would have heard, I've said a lot about effect measures. So this is what effect measures are. So in lecture one, lecture zero, we spoke about study designs and what they measure. If you've forgotten, go and visit back the lectures. But binary outcome simply means I have a disease and I don't have yes, no. And generally what we assess the effect measure in these things are either the risk ratio or the odds ratio. So how likely are you to have a disease or what are the odds of you having a disease? So one is a probability and one is the inverse of a probability or the reciprocal of the probability. And for you to do that for binary outcomes, you just need the events per each group. So how many people had, let's take stroke in the group that was obese, and how many people did not have stroke in the group that was not obese, and then you compare, and that's how you're going to get the odds ratio or the relative risk ratio. Now for continuous outcomes, so things like um, blood pressure, which it has a mean and a standard deviation. So all what we need is the mean difference. So what's the mean difference between the group that had stroke and the group that did not have stroke for blood pressure? And what was the standard deviation? And then what is the standardized mean difference? So that's basically how it's measured. And so you will need the mean, the standard deviation, and the numbers per group. Are the things you need to put in your software to calculate. So when we do your systematic reviews, when your topics are completed, if the studies are uniform enough, as Professor Edung said, then we would help you. We would do the meta-analysis. I mean, you guys will not do it, I will do it. But you're going to have your hands on board so that you understand how the process works. But that's it. Yes, so effect measures, we have binary outcomes, you have risk ratio and odds ratio, and then you have the standardized mean for continuous outcome. Just three things you need to know: one, two, and three. That's it. And then you have the needs. So very simple. Now, when we measure the effects, right? So if you're measuring the effects of BMI on having stroke, there are two assumptions that we make. The first one is that the effect is the same in all the studies. So you see the effect is the same in all the studies. That's the first assumption. So if we assume that, what your analysis is going to have is what we call a fixed effect model. It's as simple as that, straightforward. Now, the second one is that, which is what most people use, is that the effect would vary between studies. So it cannot be the same if we have 100 studies and we're going to do a meta-analysis on them. This effects cannot be different. And so that's what is called the random effects model. So it just simply says that effects varies across studies. So there is an underlying different effect. So the rule of thumb is if your studies are very similar, right? You can use a fixed effect model. So this is if you want to start using the study, but we're going to see the models in the papers. And if your studies differ, you just need to use the random effect model. By default, most people use the random effect model, so we don't even stress about using a fixed effect again. But that's basically it. Professor Elone, Joseph, can you tell me when you would decide to use a fixed effect model and when you decide to use a random effect model in a meta-analysis? Professor Elone is sleeping. Professor Tagwenang, I hope I pronounced your name well. Frank, can you tell us when we can use a fixed effect model or not?
Doctor, from what I understood, can you a fixed model, a fixed effect model, when maybe the population and the intervention are clearly defined, and there is a link between the question we're asking and the outcome are clearly linked. Now, we can use a random when maybe the population and the outcomes are not clearly linked, like they're not, how to explain it, but they're not directly understandable. So that you can use random in order to bring them all together.
Thank you very much. That's a very good try. So, all what we are saying is that the effects vary from study that was conducted by Professor Tangwenang, and a study that was conducted by Professor Edung, and a study that was conducted by Professor Shifu, and another one that was conducted by Professor Langtum. So, if all of you conduct different studies, they are going. If they vary, then we use a random effect. If they are very the same, then we are going to use a fixed effect model. All right, good. Thank you very much. So, because the studies vary, we also talk about heterogeneity. I mean, you guys are going to read about these things, but it's easy. So, we have clinical heterogeneity, which means the population and the intervention differ. So, maybe it's people with diabetes compared to risks of stroke, or people who are just obese compared to risks of stroke. So, it varies. So the studies are heterogeneous or methodological. So some people did a randomized control trial, some people did a case control study, um, using different methods. And then the last one is statistical heterogeneity. So the results are they are haywire. So are the things that bring heterogeneity. And how we report heterogeneity in systematic reviews is that we use the I-square value. And the higher the I-square value, the more heterogeneous it is. As a rule of thumb, if it is greater than 75, 50 to 75 is acceptable. If it's greater than 75, the study is so heterogeneous that you should not consider doing a meta-analysis as well. But yeah, that's just what you should pay attention to. And then the chi-square test also helps us to know if there is some evidence of heterogeneity within the studies that you have selected. But generally, high heterogeneity implies that you should interpret your results with caution, and you should consider using a random model or go to narrative synthesis. So that's it. So if your I square is very high, generally they always prefer that homogeneous studies less than 50%. You can use a fixed effect model. Greater than 50%, a random effect model. When it goes above 75, consider doing a narrative review. So, but that is if your study is going to be a meta-analysis. So I'm not going to bother you guys about it. The what's most important is that you are going to read a lot of systematic reviews. And if you're going to write one, you're going to meet this plot that we call a forest plot. So the anatomy of the forest plot is very simple. It presents how the effect sizes, how the outcome of the studies have been reported. So this line of no significance, this vertical line is a line of no effect. Generally, if studies cross the line of no effect, it means if any study crosses the line of no effect, it means that it was not statistically significant and the effects are not statistically significant. So in this demo, all of the studies are not statistically significant, but in the studies I showed you guys, we are going to see it. Now, um, the sizes of the sizes of the boxes, right? Tells us the sample size of each of the studies. So you might see some with a very large size and something. And then the width of this line tells you the confidence interval. So if it's a very wide confidence interval, it means that the study is not very specific. So that's it. And then the diamond at the bottom tells us basically the pooled effect. So the effect from all of the studies. So this is the effect from one study, effect from one study, one study, one study. And then when we combine all of them, it gives us a diamond. So if you see, that's why in the first image you had a diamond there because I was trying to pull your eyes to this. But that's how you do it. So when not to do a meta-analysis. So do not pull when Lydia, can you read for us? No. Afayi, can you read for us?
one, outcomes are not comparable. That is different definitions, scale without conversions. Two, interventions slash comparators are fundamentally different. Three, directors' designs are too heterogeneous for a meaningful pool estimate. Four, you have insufficient data for an effect measure. And five, alternative, robust narrative synthesis and clear tables slash visuals.
Good. Thank you very much. So that's it. If you don't have any of this, then go back to a narrative review. Now, last but not the least, Lydia, can you read for us what are the common mistakes for people who want to do a meta-analysis?
Mm. Common mistakes: mixing outcomes that aren't comparable, pooling because software allows it, not because it's meaningful, ignoring the risk of bias when interpreting findings, overclaiming certainty. Next session grade: writing results like a literature review, not a synthesis.
Good. So the very last session of this program is going to be about writing for publication, and I'm going to give you guys the differences between writing your introduction and writing your synthesis. So that's going to be important. About the methods and results is just to report what you have done, so it's easy, and we are going to use the Prisma flow. But this is very important, that what you write in your literature review is different from how you write your synthesis. But yeah, we are going to talk about synthesis when we in the next session. So I'm going to explain to you guys when we talk about what certainty means in a systematic review. But these are the common mistakes. So that said, this is time for us to look at the papers I sent to you guys. So just to highlight, the first paper has a meta-analysis, so we're going to see the meta-analysis output. The second paper is a systematic review without the meta-analysis, so you're just going to see where we don't need to do anything, right? And then the next one is a scoping review, which is what I did. And this one is a mapping. It shows the broadness of literature. And then these are just plots so that you see how this plot looks like in a real study. So I'm going to switch my screens here. Mhm. Any questions at this point? Do we have any question? All right, I take silence for no questions. So I am going to proceed. Wait. Yeah, so I've prepared you guys a handout that you guys will use for the next assignment. So um, unless you are very stubborn, this should be very easy. So this is what I'm going to send to you guys after this lecture, which is your handout, and this is how you're going to use it to do the next phase of synthesis. So you see, if your studies are comparable enough, then we can do a data analysis, a meta-analysis. If they are too different to pull, then you should do a structural narrative review. That's a summary of this lesson. And I've given you guys a step. So now let's go back to these are the papers that we are looking at. So let's start with Katz et al., which has a meta-analysis. Yeah, so this is the paper. So it is digital interventions for hypertension management in the US. Honestly, this is a very nice study that I want to do myself. So if any of you is interested, we can use it as one of your topics, and we can do it for Africa, not the US, sub-Saharan Africa. So digital interventions for management of that. So I'm going to ask somebody to read only the key points, not the abstract, because the abstract is a little bit long. We don't have much time, but only the key points. Who has not spoken? Mm. Oh, Joseph has run away. All right. So, Frank, can you read the key points?
Okay, doctor. The key point, the question: are digital health interventions associated with reducing blood pressure levels in the United States population experiencing health disparities? And what type of tailored modalities have been used to manage hypertension in demographically and socio-economically diverse subgroups? Findings: in this systematic review and meta-analysis of 28 studies, patients with health disparities receiving a digital health intervention compared with standard care had greater reductions in systolic blood pressure at 6 and 12 months. Most studies involve multi-component interventions, primarily remote blood pressure monitoring, meaning these findings suggest that digital health interventions are associated with improved blood pressure levels in populations experiencing health disparities.
Good. So, Frank, stay. Don't go off. What outcome do you think they are going to pull for their meta-analysis? Yeah.
Doctor, I think the outcome will be to evaluate the effectiveness of the blood pressure monitoring. The outcome will be to check for the blood pressure level, like the increase in the blood pressure level or decrease in the blood pressure level with the control that they are putting in place or the intervention being put in place.
Good. And the intervention is
Intervention is digital health.
good. Digital health tools, mainly remote monitoring, remote blood pressure monitoring. So yes, the outcome of interest is blood pressure. So you see that like what we said earlier, this the primary outcome will be reduced blood pressure. And then you see again the secondary outcome is this second paragraph. What types of tailor modalities, blah 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 blah, by demography and socioeconomic status. So that's it. So let's look at the forest plot for this study. Um, Bro, why are you not moving? Good. Let's look at the figures. So I'm just going to go straight to the figures because that's what I want to show you guys. So this is the Prisma flowchart. This is what we are going to do when we start doing your systematic review. But yeah, so in the end, they included 28 studies. Now, this is now figure 2, which shows the differences in systolic blood pressure. That is their primary outcome from baseline to follow-up time points between digital health interventions and control group. So the treatment group received a digital intervention. So it might be that somebody was taking their blood pressure and reporting it to their doctor, or reporting it to the nurse, or the people that were just coming to the hospital every month. So that's what they measured. So what did they measure? They measured the mean blood pressure. Remember in our slides, we said if the outcome is like blood pressure that is continuous, what we need is a mean blood pressure to measure. So you see, these are the studies that did a 3 months follow-up. These are the studies that did a 6 months follow-up. So they've divided it into two big classes. And then now they have put together the change in mean blood pressure between people that did not receive the digital intervention and people that received the digital intervention. So when you look at this is a forest plot, and this is what I was saying. So this line simply tells us that is a line that you should not cross. It's a line of no significance, right? And the diamond is a pooled effect. So you see that this diamond is white and it touches this line. So we are already saying that the pool effect is most likely not significant for measurement up to 3 months. That's just what we are saying. And again, we had 3 studies, and of those 3 studies, one person was significant because he did not touch the line, he did not cross the line. And he was on the left side, so which means he favors blood pressure reduction. And then so treatment favors blood pressure reduction. That's why it says there. And then this one controls favor. So if he was on this side, it means so this is the only study that stood out there. That's how we read the forest plot. Now let's look at the people that the studies that looked at a 6 months follow-up. Again, you see, now look at the
Doctor, I have an issue.
yes.
Please, can you repeat that part again? I did not really get it.
So what I'm saying is that I'm going to zoom in again. What I'm saying is that the first thing when you take a forest plot, you need to appreciate the groups that are being controlled. From the title, you know. But again, we have two separations here, 3 months and 6 months. So we're looking at 3 months first. And so we have just three studies. Now, when you look at this line, is the line is the most important line of no difference. If the study crosses this line, it means there's no significance. That's the first thing. That's why you need to pay attention. So we look at this and we count one. This one crossed the confidence interval, like we said in the lecture. This is a confidence interval, it crosses. And then this is a confidence interval, it crosses as well, but it's very narrow. Now, what did we say about the size of the squares in the class? What did we say about the size of squares?
That
We
the
said it
size of the
increase the
square,
sample size.
Agbo, go for it.
yes, doctor, that the size of the square actually covers the portion, all right, so it covers the included area or the
Now, what's the meaning of the size of the squares? What does the size of the square tell you?
Doctor, I think it's the sample size.
All right, thank you very much. Yes, it's a sample size of I. So yes, so we see that the size of the square, the smaller the size of the square, the smaller the sample size. The larger it is, the larger the sample size. And so if we see there, so this one was a smaller sample. If you look at it again, it's 74 patients and 27 patients. This is 209 and 202. So this is a very large study. And then this is 25, 25. This is a small study. So that's what the size tells us. Now, again, this line tells you that if you touch me, you are not significant. So this one is touching me, this one is touching me, it's not significant. But this one is not touching me, so he is significant. But now, what is he favoring? You look at it, favors treatment. So it means that in this study, people who took the digital health intervention had a reduction in their blood pressure because their study's confidence interval was on this side. Although it was very wide. But yeah, that's what it means. And then when we combine all of the studies, it gives us a diamond. So in the slides, the very first slide, when we're talking about systematic review, meta-analysis, you saw the diamond there. So the diamond normally should not cross the line if it has to be significant. So, but this diamond has crossed the line. So we are already saying that combining these three studies, pulling these three studies, let me use the real word, pulling these three studies together, at 3 months, digital health interventions did not statistically significantly favor the reduction of blood pressure. But it's going to be different when we look at it at 6 months, and then at 12 months, and then at 18 months. 18 months, you see that it is very favorable. It does not even touch. 12 months, you see that it's very close, right? Here it crosses. So we see that digital health interventions favored blood pressure very well after 18 months of treatment. And we see that all the studies at 18 months, the two studies at 18 months, they had a relatively larger sample size because it's 103, 133. And then their confidence intervals were very short compared to these other guys who had very wide confidence intervals. So that's how you interpret the forest plot. I mean, that's it. Um, the same thing, this is another example now, but this now looks at a different time point and it still says the same thing. So you have it. And then what I wanted to show you guys now is now the table one, which is the study characteristics. So you see now that this is the first part of your extraction sheet that we were looking at. So author and year, was the study a pilot study or not? Yes, no, yes, no, yes, no. What was the study population? Individuals with acute ischemic stroke, Black African Americans, individuals with uncontrolled hypertension, Black African Americans with hypertension and all diabetes. So you see that the populations are comparable to a certain level, but they have one outcome. And then what was the disparities in those clinics? Da, 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 da. And then follow up duration. And then was remote monitoring included or not? Where was the study carried out? So that's table one for it. And then you have now an assessment of the intervention of the various components of a digital thing. So this they're trying to discuss what type of digital intervention was done. They put it in a different table. And yes, that's the first study. So do you guys, the goal of this is for you guys to see where you're going to. Do you guys see what will be expected of you if your study is going to have a meta-analysis? Do you guys also see why the extraction sheet was that detailed? Because you need to report some of these things. Now, it is not exactly the same with what we did, but it has some things, and you see that you have to adjust it by study by study. Good.
Please, doctor, I have a question.
Go for it.
My question is about the forest plot. Since, from if I understood well, the forest plot is based on the study significance. So I wanted to know what what issues the significance to this study. Is it a kind of a software, or we are the ones through reading the
No, no,
stating the study significant or not?
no. This is done by software. So you put all those values together, and then we'll do it on the software.
Okay,
And
doctor.
then you will have the forest plot, and then you interpret it based on the values you see.
Okay, doctor.
Mhm. It's not manually calculated. Very good question. No, nobody does that. All right. Now, our next paper is this one that does not have a systematic a meta-analysis. So it is randomized clinical trials of machine learning in healthcare. So this is a very broad study. Lydia, can you read the key points?
Key points. Question: how are machine learning interventions being incorporated into randomized clinical trials in healthcare? Findings: in this systematic review of 41 randomized controlled trials of machine learning interventions, despite the large number of medical machine learning-based algorithms in development, few randomized controlled trials for these technologies have been conducted. Of published randomized controlled trials, most did not fully adhere to accepted reporting guidelines and had limited inclusion of participants from underrepresented minority groups, meaning these findings highlight areas of concern regarding the quality of medical machine learning randomized controlled trials and suggest opportunities to improve reporting transparency and inclusivity, which should be considered in the design and publication of future trials.
All right. Thank you very much. Stay, don't go off. Why do you think we cannot do a meta-analysis for this study? Just from reading the key points.
Okay. They said that this randomized control, that some of them did not report did not respect guidelines in their reporting. And yeah, that one in particular, I've already disturbed.
No, read only the question. The answer is only in the question.
Any interventions being incorporated into. Okay, there are many different ways in which machine learning can be incorporated into randomized control trials. So it's going to produce multiple outcomes. The results are not going to be similar.
Good. That's the word. Similar, uniform. Yes. The question is how, right? It is not like the other one which said um um digital health hypertension. Where is their research question? Where is it? Are digital health, so this one was very clear, are digital health associated with reducing BP? But yeah, they're just like, well, we don't know. How? We just want to find out, right? So you cannot do a meta-analysis with this kind of equation. So that's it. So, but if we look at their figures, you would see again the same thing. And then you see that they have a mapping of where the studies came from. which is not what we saw in the other study. So it's not, it's a different presentation. And then they have bar charts just telling us trials over time, but this is more descriptive and really structured. And you see that it is not talking about study by study, but they're talking more about particular groups like, okay, clinical trials per country, clinical trials over time, um, population, demographic, and then medical specialties. So you see that they did not say study A did this, study B did that, but they try to group it in a way that makes sense. You see, that's why I was saying that it's not a study by study literature storytelling. And then you see, this is where they said very few studies use standard checklist, right? So again, they try to plot that on a graph. And then you see now risks of bias assessment. So they plotted it um, of all the studies. And you see that missing outcome data was very high in almost all of the studies, all of them, you see. And then did they assess randomization? So there were very few studies with a low risk of bias, but you see studies with randomization. So you see, again, this is how you can decide to plot your risk of bias in a study. And then you see now their table one characteristics. Again, you see it has source, it has study location, it has the aim, what was the reason for the study, and then it has percentage, ethnicity, medical specialty, and disease. So you see that some of these things keep changing, but you see that gives the description. We had something like this in our table, but we didn't have race or we didn't have medical specialty. So you see, the same thing. So that's it about this study. Um, The third study is actually my own study, which I have given to you guys a long time ago to read, but I know nobody has looked at it, so I'm bringing it again in your face. So it's the last paper we're looking at. But again, the study here is just about mapping. Joseph, are you there?
Yes, Doctor, I'm there.
Good. Can you read the heading of this study?
Mapping the evidence on health intervention for cardiovascular event care in Africa, a scoping review.
Okay, stop, don't go. Now let's come back to this. Read this one as well.
Randomized clinical trials of machine learning interventions in healthcare, a systematic review.
All right. I just want to take you back to the key question. Read the question.
How are machine learning interventions being incorporated into randomized control trials in healthcare?
So, how do you think that study differs to this one? How do these two studies differ just by reading their question and the title?
Okay, this one in particular is trying to get like the effectiveness of health interventions in cardiovascular care
Mm-mm. There's no
and
effect on that title, sir. Read the title again.
so these studies is trying to get the evidence, like the outcome on how how health interventions affect cardiovascular care in Africa.
Mhm. All right. So thank you very much. So, I mean, this is a question to the class. If your goal, right, for your systematic review is for you to see how much work has been done in your study, how would you, what kind of study would you conduct? Would you conduct a systematic review or a scoping review? Who has not spoken? Who is at risk of sleeping? I think, Patrick.
Yes, sir.
Mm-hmm. What will you do? What kind of study will you carry out?
Um, what is the research question? Let's see.
This is a research question.
Evidence of interventions for preservation of in Africa. Doc, I think I'm going to conduct a narrative synthesis here.
All right. Anyways, that's fine. So let's look at the difference between this. So the goal is that if you don't know what has been done in the field, it's always good to start with a scoping review. So
Uh-huh.
you discuss how broad the knowledge is in that field. So that's it.
Uh-huh.
Again, it's still the same thing. We still have a Prisma flow chart. And then I mean you see here what I did was I plotted the number of studies using the African map because it's an African study, right? And then by virtue of the intervention type that was used, so was it preventative care or was it therapeutic care? And what type of cardiovascular event did we have? Did we have stroke or STEMI? So again, that's it. And then looking at it, we also looked at the distribution of what type of technologies were being used in cardiovascular event care. So you see again, here it's not a study by study, but we have particular themes or questions to answer. Range of technologies used, where, when, and how are mHealth applied in cardiovascular events in health systems in Africa, and then mHealth tools and their outcomes, and then implementation challenges and lessons learned. So all of this is just from the studies, and that's it. So you see that here again, it's not a paper by paper review, but it's more on the details. So the other papers that have figures, I'm going to send this with you. You guys are going to look at the figures. So, but it's just for you to see how these figures are done in a scientific study. So this one has a heat map. Um, Figures. Again, this is a network analysis, but um, I don't think we'll be doing it. But this is a type of a heat map. This is the typical heat map. You guys would have seen this in your WHO cardiovascular disease guidelines or pediatrics handout for asthma severity, all those things. So you see, that's what the heat map looks like. And then you grade the score. So that's heat map. Simple. And then um, this one has this one has, again, we always see, so this one now has kind of bubbles, but it just gives you an idea of where the evidence has been, and then they change it. So you see that the size of the bubble or the color of the bubble represents the number of studies that were included in the study. And then they still have their table again. And then last but not the least, yeah, okay, I had opened this one. So this one has this is what we were talking about, a a harvest plot. So this is a typical, very non so very classical harvest plot that you'll see. But I mean, it's just to show how studies, the findings from studies have come out over time instead of writing it. So you just put boxes or you put things. So that's it. But not a very beautiful flow. But I mean, I hope you guys get the gist of it. I mean, the solitude is very cited. So that's it. Now we are going to move to your presentations. If there are any questions about this, I'm going to send this handout to you. I've really designed it. At the end of it, you will have, this is your assignment. It's very well written there. I've highlighted it in red for you guys to do. And the assignment is really to use back those 7 things, the studies that you use for extraction. But now is your time to take the stage and talk about extraction. So who wants to go first? I have 3 people who sent me their files. So do you want me to share your files or do you want to share from your end?
Please, before we move to the presentations, concerning the assignment, uh, concerning the assignment for the next section, you said this synthesis is mainly done by using software. So I don't understand which software are you to use. to do the various synthesis because I don't know.
No, synthesis is not done by software. Synthesis is done by you and your brain and your Microsoft Word and the Excel sheet of your extraction. You guys are not going to do any. You guys are not going to do meta-analysis. You guys are going to do narrative synthesis. That's the task, right? For to answer this question, among Africans with CVD, do ML that prediction improve the prediction of cardiovascular events in, compared to that. So that's it. So, Patrick, can you read the assignment?
So the assignment is saying using our questions of among African adults of at risk of cardiovascular disease to AI or machine learning based cardiovascular risk prediction models improve the prediction of cardiovascular events compared with conventional risk scores. So your group first using the seven included studies will be extracted and appraised. So we synthesize the findings across studies, decide whether a meta-analysis is appropriate, justify a decision clearly, prepare a strategy presentation for the next session. And what the group will do, review the expected data and the risk of bias for all the seven studies. Group studies by outcome, model type, and territorial population. Judge whether the studies are similar enough for meta-analysis. If yes, identify the effect measure to at different needs and prepare a simple code analysis or mock response plan. So now, from what they are saying, we are clearly answering, okay, five. There is from three, just whether the studies are similar enough for meta analysis. So is it that the seven studies are clearly not enough, or I don't know. Because you
No,
just said you're going to.
no. The point is the point of this lecture, right? At the end of your systematic review, you're going to have 7, 10, 15 studies. You're going to look at the effect size and say, oh, do I need to do this meta-analysis or not? So that's the task what I'm giving you here. Judge whether the studies are similar enough. That's what we've been discussing throughout this session, right? Are the studies similar enough for a meta-analysis or not? So that's it. And this is nice to have. If yes, just discuss how, if you were to do a meta-analysis, you go about it, right? That's it. I don't need you to do a meta-analysis. Just talk about your goal. If you think that the studies were similar enough to do a meta-analysis, tell us how, what is the effect size you're going to do, what is the data that you're going to present for that study. That's it. You're not doing their meta-analysis, right? And it's really a plan. If no, if no, then to
There is
continue.
structural narrative and six, explain how risk of bias affects your interpretation. And want to present next session in 5 to 7 minutes per day. Your synthesis approach, that is in the narrative or meta-analysis, why that approach is appropriate, one summary table that's go. Your main finding conclusion for this sample for this sample review. Use lessons from the system, the narrative synthesis, stream logic, effect measure, forest plot, heterogeneity, and risk of bias in form interpretation. And a key reminder, not force for meta-analysis. The goal is to choose the most appropriate synthesis method for the available studies.
Is the assignment clear?
The
No,
assignment is clear. For 1 week, I think 1 week is 100.
For only 7 studies. What if you had 50?
Well, it's, oh, okay. But it's not like we're just focusing on that the whole day. We also have we also have some duties to carry out. Maybe people like
Should
I don't
I
know.
should I give you my life and take your own?
No, that's not what it said though. I'm
All
not
right.
talking about
All right, you
Thank
guys are
you.
you guys so is 1 week, is it, let's let Patrick don't overshadow the class. Is 1 week enough for you guys to do the assignment? You guys are going to work in teams. You're not doing it alone. At least there are 3 groups. Is 1 week enough or not? Lydia, you are the class representative. You guys are going to, what do you think? You guys are going to brainstorm and give me your own deadline that you want to submit this assignment. Is that okay?
Yes, doctor. But I would just like to say that the 1 week is not going to be enough because from the previous assignment we had, it was a really big struggle. So we were going to work on the date, but 1 week is not going to do.
All right, so that's 2 votes that 1 week is not enough. I'm not going to ask the other people. Afai, do you think you can do it in 2 days?
Difficult because next week they are evaluating us in our respective hospitals.
It's okay. All right, you guys are going to tell me when you guys want to submit this, but I mean, it's you guys need to do it. So, any other worries about the assignment? I mean, I'm going to read again through and then make it very clear, highlight the things. You guys are not doing meta-analysis. If you think that the studies are similar enough to the meta-analysis, then give give us your meta-analysis plan. Yes, Lydia, your hand is raised.
Doctor, I wish to ask if it's possible to break the assignment into two so that for next session we could have something to show for at least.
All right. So you guys should. I'll give you guys the assignment, right? You guys should break it into two and say, okay, this is what we'll present next week, and this is what we'll present the week after next. That's fine.
Okay, doctor.
Yeah. But that just means that I'm not going to give you guys an assignment next week since you guys will carry this one for 2 weeks. So I'm going to see how to, because I mean the next session is easy. It's just what's on that timetable again? The next session is easy. Yeah. The next session next week is about interpretation. So you might not have an assignment. It's still part of synthesis, which is writing your interpretation and conclusion. So it's still part of the synthesis, so it's fine. You guys will not have an assignment. Yeah, you guys will continue doing this one. So but break the assignment into two and let me know what you guys want to present next week. All right. That's why I put the timetable in all of the documents so that it helps me to always check when I'm doing something. So that I don't overdo something in one lecture, which does not would overshadow another one. Any other question? Agbo, are you there?
Yes, doctor, I'm there. Actually, I agree very much with Lydia, especially for the 2 weeks part. 1 week, for me personally, it's always very difficult for me to do the assignment in 1 week because I always have to review what we did again during the weekend, during it takes me much time. So I, I'm okay with what's there, especially with the part that we should have something to show for in 1 week. It should not be that because the homework is in 2 weeks, we should give it only in 2 weeks. We have something to show for in 1 week so that at least we know that we are doing progress.
All right, that's fine. Good. So, let's make progress. So, like I said, 3 people sent me their extraction. So, Afai, Lydia, and Patrick. So, who wants to present? Or do you
I
guys
want to try
you want to try? Good.
for some
All right.
studies though.
All right. So I'm going to put you on the hot seat. Um,
Should I share my screen though? Although my laptop
oh,
is
you
not
want to share your
working.
screen?
Yes, though.
Yeah, sure. With pleasure, you can go for it. I've stopped sharing so that you can share.
Can everyone get me now?
We can hear you, but your screen is still starting to share. I mean, from my end, I cannot see your screen. I just see that you have started sharing. Yep, I can see your screen now, Professor. West Coast 2024. CAMESA. Online appeal. Research. SCOPH.
Okay, Doc, for the sake of time,
GTA.
I'll just go straight.
Yes, go straight to the point, sir. Yeah.
So, Doc, since the study involved the cardiovascular and machine learning and all these things, so I did not really understand the concept of the column. So, the first part of my work was to get to understand the respective part of the column that we had in our extraction sheet, which I've just shared here, like the study, the PMIT, the TOI, the first order, and other concepts as we move forward. So what I did is to go online and then to check the meaning, which is what I have in this document. So the study ID, I had the definition with sample examples to assist me on how I'll write it. Now, coming to the studies per se, the first study that I extracted was was the comparing conventional statistic model and machine learning by Premaga AI. So what I did was I used the Word document to directly apply to what we did the last class. So I think this is not it. Okay, I think this is the article. So concerning the IT, the study information, I just looked at the title, got the first author, and then I think the study IT is this HTTP link here. So
Mm.
when I was reading, I just copied it directly from here and then pasted. Then I proceeded now to my abstract, especially the method section now, where I could get information now about the study itself. So yeah, I already have the kind of study which is a retrospective study, and then
Mm.
I have the, the recruiting years. I think there was something like that between 2002 to 2008. I have the settings already in my methods, which I just copied from here directly to my Excel file, which is here. So here, the first author, the year, and then the title, and then so now the next part of it now was to analyze the title section of the study, which I did. So I went to state topic.
You did not download the PDF on your laptop.
So my laptop got bad, so
Mm.
I lost some files. That's why I had to do it towards the end of the week. So I went to the title section of the methods. That's where I got more information, like here. Now,
Mm.
there are certain things already that were stated up there. So for like, I have the journal. The journal as well. I copied the country. I copied directly, and then the mean age, for instance, and the sample size. So I started again. I read through detailing, and then I looked at the table that had all those information. And in this particular study, I think this is the table. I think this is the table where I had my sample size, because here we have total. I copied female and male, So I added them both to have my total, my sample size. And then for the female, I think there was a section that I talked about percentage female. So I had 80 divided by the total. I think it was something like 173, then multiplied by 100 to get what I wanted. Then I think each, there was a section for each as well. I think this is the age, the mean age that was here was 51 point, the combined mean age was 51.7 something. So I just rounded it up and then copied the data to include. Um,
All right.
yes, I
Just
thought this.
walk us through your Excel sheet, right? I understand how you copy your information and the rest. That's very, very good. So just walk us through the various columns in the in the
The
Excel
Excel.
sheet. Mhm.
So you have the ID, the first author, the year, title, the journal, country, the region. But I have to say the region and this particular region, I didn't do it since I was working with Lydia. I just took what she had done because when I was trying to, I did not really understand how to get that info. So it is, since we had the deadline to submit, I just submitted probably to understand later. So here is my percentage, the key risk factors. I got them directly. Target outcome, most of the papers reported their target outcome directly. Then outcome of outcome ascertainment. Yes, so most papers equally reported how they made sure that the information that they had was accurate. So that is a prediction horizon. I didn't understand that. That's why I did not include it. And then if the AI or machine learning was used, most papers reported the use and then they gave the algorithms that was involved. Then I equally did a bit of research to know about the algorithm, the big algorithm families, which I showed in my Word document earlier, and then the specific algorithm. All the papers reported the specific algorithm, but my worry came. I don't know if what I did was correct. Was at the level of the external validation. For that definition, if I'm not correct, I think it should be the method that was used to kind of evaluate the model performance using the data that was used to provide using the data that was used to provide to develop the model itself. That's for internal validation. But if that method was used to evaluate maybe data that was not used to produce to produce the model, then that is external validation. But most papers do not report that directly. So I assume that if any paper did not report it directly, then there was no external validation. If they evaluated just the data, the initial data or the data that was used to develop those models, I considered it as no. Although I think there was one paper that there was a paper that had where they evaluated, there was an external, the one concerning the UK bank.
All right, Afai, I'm going to cut you, right? You've taken more than 5 minutes, but again, very good work. Very proud of what you've done. There's nothing I would fault you for. I, I believe you send the sheet to me. So for those of you sending the sheet to me, I'm going to take out time and give you particular reply to your mail with a little review. Um so that it's going to guide you when you're doing your synthesis. But again, that's why I said, guys, ask your questions on the forum when you're doing the assignment, when you're working in a group, so that I can answer them. But nobody asks the question. So external validation simply means that they've built a model and then they say in their study that this model was later tested in another hospital in another setting, or we had data and we'd used 80% of it to train the model and then 20% of it to validate the model. So that's what we mean by external validation. So that needs to be reported. This study is a technical study. I'm doing AI and machine learning in my PhD. So I did not expect you guys to have that technical knowledge, but what you did that is very good is that you actually went to the internet to search some of these terminologies, and I bet you will not forget because you've done that work. But if you search and you don't see, drop the question on the WhatsApp forum. I've never beaten anybody who asked the question on the WhatsApp. But very good work. This is how you do extraction. You actually go to the studies and copy and paste. You don't invent anything. So the key learning for all of you, especially those who didn't do this already, is that you are just being a journalist in this thing. Where the work is actually what you guys have to do next week, which is synthesis. That's where, after you've done all of this journalism that Afayi has elaborated here, you are then going now to say, okay, how can I make sense of this thing that I have written? And that is where synthesis starts. So Afayi, thank you very much. I don't know if I've answered all your worries, but if there are any worries, please feel free to ask now.
No, no, please. That was my boy. And then the PMIT, though, I don't know where to get it.
PMID is a PubMed ID. You get it when you download the paper from PubMed, or if you go to PubMed, you see there. They did not tell you what PMID is when you search on the internet, sir.
No, they told me, but just that I tried to look for it, but it's not.
I mean, so what you do, right? Just put the study on PubMed. Just copy the title of the study on PubMed and put it on PubMed. You see it there. Yeah. But very good. Very, 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 very good. Very good work. So I'm very much looking forward to your synthesis because that's why I'm going to test how much how much you retain from this study. But that's fine. Very nice. Any other person wants to present? Patrick, Lydia?
Okay, doctor, let me try.
Yeah.
Mm, doctor, please share. I'm not able to share my screen. I'm using my phone.
Yeah, using your phone. How much are you paying me to be a sharer? Mm.
Okay, nothing for now.
Okay. Let me share then. Let me look for you. All right. Where did that document go to? You sent me just one, right? You sent me the MM80 is I'm going to look at it, but what I need to see is what the MM80, like you see from what the sample that the text I give you guys, you just need to report one sentence or a few sentences about your bias.
Yeah, I think I sent it to. Let me resend it again on
No, no,
WhatsApp.
no, no,
I
no.
sent.
I have both. I'm just saying that you're going to present only the the
Extra.
expression. Yeah.
Okay, doctor.
All right. There you go. Those are your 7 studies. Should I zoom in?
No, no, it's okay. It's okay. I can see.
Hmm.
All right. So yeah, I just got the correction for the PubMed ID. I know where the ID work could be gotten from, but somehow I did not. I expected that it would be on the paper, and if it was not reported on the paper, I don't know. I have to go to PubMed to go and copy and paste from there and copy from
You can
there.
also see it on the paper. It's always there.
I
Maybe
saw
uh,
the
uh,
DUI.
All right, nice. So I mean, DOI is fine. Permanent ID is a nice to have, but if you have DOI, it's fine. Good.
Mm. And
So
then
walk us through your sheet.
yeah, so I copied the first author names were all there. The years, some studies said 20, like one they said 2024, 2025. I just took the year in which the publication was actually made, and
Good.
then
That's the
the
strategy.
title.
When it was published. That's the year.
Yes, doctor.
Good. Go for it.
And then the next we have the titles, the respective journals, the
Mm-hmm.
countries, and then the regions. At first, I thought it was just sub-Saharan Africa, but apparently you have to put the specific region as well.
Because we're in sub-Saharan Africa already. The studies for sub-Saharan Africa, right?
Yes, doctor.
But yeah.
Yes.
Mm-hmm.
Okay. The issue with setting, well, I understood that setting had to do the with where the data was coming from. So at some point, I did not know. Like for example, this one was the UK Biobank, and this was actually the UK Biobank is not sub-Saharan Africa, but they
Mm-hmm.
did their internal validation for Kenya. So that particular study got me very confused.
Yeah, that was very intentional for you guys to have it inside. Yeah. Mm-hmm.
So,
Continue.
okay. And then the study designs, most of them were retrospective data driven studies. And then there's, let me see.
Data source.
Yeah. The recruitment, yes, some studies did not report when they recruited their data. I was not sure if I was the one who could not find it in the articles or if it was really not reported. Then there's the eligibility summary. This was in the method section.
Mm-hmm. Right.
And
You
there's
have a minute. I
oh,
mean, what I'm seeing is very nice. I'm trying to see where there's an error which I cannot picture, prediction horizon, not no information. So by prediction horizon, right, it's like trying to see, um, because I think that's one of the things that you guys could not report, but I mean, it's also fine if you guys cannot report it. It's really a niche topic. So it's to see like the models, right? How
yeah.
how precise was it? How was the accuracy of the prediction appreciated by the researchers? So that's what I meant by prediction horizon. But I think the the mistake I made, which I'm happy that you guys took the pain, which is also a good learning experience, was that I would have given you guys a code sheet. I used to build this to give you an explanation of what the variables on the columns meant, but you guys have already figured it out, so it's fine.
Mm, okay. So all the studies used, they were all machine learning AI, and for the next they mostly they reported the specific algorithms, so they did not really have like algorithm families. I think I was supposed to go and find the
Yeah.
specific algorithm families for all of those.
Mhm. But I mean, if you already have the specific algorithm, it's fine. You can, when you're synthesizing, you can do that. So that's okay.
Okay.
Mhm.
And then, well, yes, the prediction domains was okay. The number of predictors, some of them did not report it, and I could not find it, so I was not sure if it was that it was problem on my end or the article itself.
What did you do when you could not find it? Did you ask somebody else? Did you ask it in the group? No, you stayed in your corner. You guys are doing the same program, all of you, and you guys are behaving as if you're in your own city and
Wisdom, I have a
nobody else.
question
Yeah,
concerning that
go for it.
number of for the number of prediction.
Your volume is low. Can you be loud a little bit?
Can you get me now, Doc?
Yes.
Yes, I was talking about the
Mm-hmm.
prediction domain, the number of prediction domain. When it's true, I had the same issue. Some studies did not actually report it directly, but when you read through, you see that they actually stated those predictor domain makes socio-demographic
Mm-hmm.
information, diagnosis, and all of that. Are you to count? Are you to count what was stated and then you write it, you put the number?
No, I mean just put the things there now. You're always counting later. In doing extraction, the work you are doing is being a journalist. You are just copying and pasting.
Okay, okay.
Yeah. I mean, one of the things I was expecting you guys to do was to say, Doctor, there were some things that we could not gather because this sheet did not have it. And so I added an extra column, but nobody has done it. But it's okay. Lydia, are you done? I've,
Um, Doctor, so I've just skipped to my notes. There were some two studies there which did not, like the one that recorded instead cardiovascular disease risk factor instead of predicting the cardiovascular disease itself. So they were studying like presence of diabetes, hypertension instead of a cardiovascular disease like stroke, coronary artery disease. So I wanted to ask if this study is still going to be included.
we are
And then there
looking
was another
we are looking at
um
yeah, go for it. Yeah.
another one that was studying post surgery survival. So that one was not it was these are all patients who already have the cardiovascular disease, the I think it was coronary artery disease. All of them already have a cardiovascular disease. So the outcome in that case was not really
Was it
aligning with such
good?
question.
Yeah, because those were the yellow studies that I said maybe, and we've not had that discussion. But the studies that have the you're so I'm in what I'm going to say, you're going to work with just four studies and not the seven because um those three, none of them, I think it's just one that has to be included. The one that is post-surgery definitely has to go out. And then there's another one. I've forgotten the details, but yeah. But that was one of my. I thank God you are bringing it up. But the yellow papers were intentionally I inserted them there because I wanted you guys to see those conflicts that you have when you have a clear category and you have papers that are very close to it. Like yeah, but that's it. So you're going to work with four of the seven, the four that were included. So in your exam, in the sheet I sent with you guys yesterday, last week, you see the four included, and then the four that may be that are yellow. I mean the other three that are maybe. So yeah, are you
Thank
happy
you,
now?
Doc. Yes, I'm done.
Mhm. Patrick, over to you. Do you want to present or should I share your sheet?
But instead, I think we are running really out of time, and I
All
think
right. You have learned.
what I was to present is similar to what Lisa and I just presented. Just
All right.
that the pop meta ID and the star ID too. So, and also I'm happy because Lydia brought what I wanted to say concerning those three stories that were maybe. So I think
Good.
they had, I think it's not be included too.
No, I mean that's why I put them maybe because if any all of you guys are smart, but you guys did not catch it. That's why I made it clear these are maybe studies because I wanted you guys to sit and think, should I really include this study or not? And then discuss among yourselves and say, no, we are not including this. Instead of reporting the seven, I'm going to report four or five because these are the three that I'm sure with my full chest that I should include. But
Because that's what we had in mind, but we just answer the assignment as you gave. We said we were to extract the seven, so that's what we're extracting the seven. That's
all right. I see. No, it's fine. It's okay. I mean, that was intentional. I mean, you guys are smart, right? I know that I'm teaching you guys new things, but I want you guys to, that's it. The reason for it, and it was very clear that it's maybe, right? Borderline papers. So sit and think of it. Should I really include it or not? Judge for yourself, but it's fine. So I'm going to allow you guys. So now you know that in your synthesis, you're going to synthesize just four papers. It's a must that you must have four papers, but have a look again at these three papers, the one by Prem Saga, the one by Tangege, and the one by Idrisu. And with your full chest, include the one that you are sure that should be included and exclude the other ones when you're doing your synthesis. So next week, we'll have you guys present the first part of your synthesis. We should have your probably your table one, right? The study characteristics, which is just copying and pasting what you already have in your extraction sheet. I think that's a very easy thing to do, right? And more, but I'll leave you guys to pick it. All right, so let's close up. And thank you guys for being part. Any questions? I mean, the last slide is just for me to share. We've already spoken about these papers, so I'm not going to talk much. So the next thing here is we've done this already. So we've looked at the assignment already, and we've looked at the assignment already. And so again, the resources are there for you guys to use. Everything is on your timetable. So you guys have contested that you guys cannot do this in 1 week, so I'm not going to read this slide again. But one thing is certain, please ask your questions on the forum, right? And then we'll make progress. And yeah, again, we have our services available for you guys to tell people of what we use. Joseph, can you read the key takeaways for today? Hello, Joseph. Joseph, yeah.
With synthesis turns studies into an answer. Use narrative synthesis when studies are too different to combine. Use meta-analysis only when studies are sufficiently comparable. Forest plots and heterogeneity help interpret pooled results. Risk of bias must inform interpretation. Choose the most appropriate, not the most complex synthesis method. Bottom line, a good review tells a clear, structured, and evidence-based story. Do not force pooling. Choose the most rigorous and meaningful way to answer the review question.
Thank you very much, Professor Elone. And with that, I would say thank you all for your kind attention. I hope this was a good lesson for you guys, and I hope you guys learned something. So, we are 25 minutes over time. So, um, let's take our family selfie, and I'll let you guys go and enjoy your Samidiswa. I'm going to stop sharing, stop recording.